The sky did not change all at once. It dimmed gradually, almost imperceptibly at first, as though daylight itself had begun to hesitate. Across distant continents, in places with no knowledge of one another, farmers looked upward with the same unease. The sun appeared muted, its light filtered through a strange haze. Weeks passed, and the change deepened. Summers grew colder. Harvests began to fail. No war had been declared, no empire had fallen, yet across the world, a silent crisis was unfolding, one that began in a remote corner of the Andes, where the earth had opened and released forces powerful enough to alter the climate of the entire planet. In the year 1600, high in the southern Peruvian Andes, the volcano Huaynaputina erupted with extraordinary violence. It was not among the tallest or most well-known volcanoes in the region, and prior to this event, it had shown little obvious sign of the devastation it was capable of unleashing. The surrounding landscape was sparsely populated, dotted with small settlements under Spanish colonial control and indigenous communities who had lived alongside the mountains for generations. For them, the land was both provider and threat, but nothing in living memory resembled what was about to occur. The eruption began in February. Initial signs likely included tremors and minor emissions of gas, though records are limited. What followed, however, was unmistakable. A massive explosive event sent a towering column of ash and gas high into the atmosphere. Pyroclastic flows, fast-moving currents of hot gas, ash, and volcanic debris swept down the slopes, destroying everything in their path. Nearby villages were buried. Agricultural land was rendered unusable. Rivers became choked with volcanic material, altering their course and contaminating water supplies. Spanish colonial records from the region describe darkness during daylight hours and ash falling like snow. Livestock perished, crops were destroyed, and survivors were forced to flee. The immediate devastation was severe, but the full impact of the eruption would extend far beyond the Andes. Huaynaputina's eruption is now understood to have been one of the largest volcanic events in South America in the last 2 millennia. It released vast quantities of sulfur dioxide into the stratosphere. There, these gases formed sulfate aerosols, tiny particles capable of reflecting sunlight back into space. This process reduced the amount of solar radiation reaching the Earth's surface, leading to a measurable drop in global temperatures. At the time, of course, no one understood the atmospheric mechanisms at work. What people experienced instead were the consequences. In the months following the eruption, unusual weather patterns began to emerge across the northern hemisphere. In parts of Europe, the summer of 1601 was notably cold. Contemporary accounts describe persistent rains, shortened growing seasons, and widespread crop failures. In some regions, harvests were reduced to a fraction of their expected yield. Grain shortages led to rising prices, placing enormous strain on already vulnerable populations. In an era when most people depended directly on local agriculture for survival, even a single failed harvest could be catastrophic. When failures occurred across multiple regions simultaneously, the effects were amplified. Food scarcity gave way to famine in certain areas, particularly in parts of Eastern Europe and Russia. In Russia, the early 17th century was already a period of political instability. The onset of severe climatic conditions exacerbated existing tensions. Crop failures between 1601 and 1603 contributed to a famine that resulted in significant loss of life. Historical estimates vary, but the scale of the crisis was profound. Social order weakened as food became scarce, and the state struggled to respond effectively. Elsewhere in Europe, the impact was uneven but still significant. France experienced poor harvests and rising grain prices. In the Scandinavian regions, colder temperatures shortened the agricultural season. Even in more temperate areas, the unpredictability of weather disrupted established farming cycles. In Asia, similar patterns were observed. In China, records from the Ming dynasty indicate unusual weather conditions, including unseasonal frosts and reduced agricultural output in certain regions. While it is difficult to attribute specific events directly to the eruption, the broader pattern of climatic disruption aligns with what is now understood about large-scale volcanic impacts. Japan also experienced cooler temperatures and poor harvests during this period. Historical documents note famine conditions in some areas, though, as in other regions, these were influenced by a combination of environmental and social factors. The global nature of these disruptions highlights the interconnectedness of Earth's climate system. A single volcanic eruption, occurring in a remote part of South America, had the capacity to influence weather patterns thousands of kilometers away. This was not immediately apparent to those living through it. For them, the causes of the hardship were often interpreted through local frameworks, religious, cultural, or political. In many societies, unusual weather was seen as a sign of divine displeasure or imbalance. Without a scientific understanding of atmospheric processes, communities sought explanations that fit within their existing worldview. This sometimes led to increased social tension, particularly in regions already facing economic or political strain. Despite the widespread impact, the eruption of Huaynaputina did not become a defining global historical event in the way that wars or major political revolutions did. Part of this is due to the nature of its effects. Unlike a single, dramatic moment of change, its consequences unfolded gradually, across different regions, and were often intertwined with other factors. Modern scientific analysis has allowed for a clearer understanding of the event. Ice core samples from polar regions contain distinct layers of sulfate deposits corresponding to the early 17th century. These layers serve as a record of atmospheric composition, preserving evidence of major volcanic eruptions. The data indicates a significant increase in sulfate concentration around 1600 to 1601, consistent with the scale of the Huaynaputina eruption. Tree ring studies provide additional insight. In many parts of the northern hemisphere, tree growth during this period was notably reduced, reflecting cooler temperatures and shorter growing seasons. These independent lines of evidence ice cores and dendrochronology align with historical accounts, reinforcing the conclusion that the eruption had a measurable global impact. Back in Peru, the local consequences remained severe long after the initial eruption. The landscape surrounding Huaynaputina was permanently altered. Thick deposits of ash and volcanic debris covered large areas, making agriculture difficult or impossible in some locations. Communities that had once depended on the land were forced to relocate or adapt to new conditions. Spanish colonial authorities documented the destruction, though their records often focused on administrative and economic concerns. Loss of agricultural productivity affected not only local populations but also the broader colonial system, which relied on resource extraction and production. Over time, vegetation slowly returned to some of the affected areas, but the recovery was uneven. Volcanic soils can eventually become fertile, but this process takes years, sometimes decades. For those who lived through the immediate aftermath, the benefits of this transformation were far in the future. The eruption also serves as an early example of how natural events can intersect with human systems in complex ways. Climate anomalies alone do not determine outcomes, their effects are shaped by social structures, economic resilience, and political stability. In regions where these systems were already under strain, the additional pressure of environmental disruption could be decisive. In Russia, for instance, the famine of the early 1600s contributed to a period known as the Time of Troubles, a phase marked by political upheaval, social unrest, and foreign intervention. While the eruption was not the sole cause, it was one of several factors that intensified existing vulnerabilities. Similarly, in parts of Europe, the combination of poor harvests and rising prices placed pressure on rural populations. In some cases, this led to migration, changes in land use, or shifts in local economies. These adjustments were often gradual, but they reflected the need to adapt to changing conditions. The Huaynaputina eruption also highlights the limits of historical awareness at the time. Without rapid communication or a global scientific framework, people experienced the effects of the event in isolation. A farmer in France, a merchant in Russia, and a villager in China might all have faced the consequences of the same eruption without any knowledge of its origin. Today, the ability to analyze such events in a global context allows for a more comprehensive understanding. Satellite observations, atmospheric modeling, and geological studies provide tools to trace the pathways through which volcanic emissions influence climate. These methods reveal patterns that would have been invisible to observers in the early 17th century. The study of past eruptions like Huaynaputina is not only of historical interest. It also informs our understanding of how similar events might affect the modern world. While contemporary societies have greater technological capacity and more diversified food systems, they are also highly interconnected. Disruptions in one region can have cascading effects through global supply chains. Large volcanic eruptions remain relatively rare, but their potential impact is significant. By examining historical examples, scientists and policymakers can better assess risks and develop strategies to mitigate the effects of future events. The story of Huaynaputina is, in many ways, a reminder of scale. It demonstrates how processes occurring deep within the Earth can influence the atmosphere, alter climate patterns, and shape human history. It also underscores the importance of perspective. Events that seem local in origin can have consequences that extend far beyond their immediate surroundings. In 1600, there was no single moment when the world recognized what had happened. There was no global awareness of a shared crisis. Instead, there were countless individual experiences, failed harvests,